So let's look at part B of this question. We have the same information, but the difference now is that the astronaut is not on the surface. The astronaut is now 7,200 kilometers above Earth's surface on a spacewalk. So if we draw that out, we would have the Earth here, and then the astronaut is right there, which is 7,200 kilometers above the surface. That is the same as 7,200,000 meters above the Earth's surface. But that's not our R. Our R is the distance between the surface and the astronaut, but it comes from the center of the object. So we also need to include that radius of Earth in there as well. So R is going to be equal to our radius, which is on our formula sheet, of 6.37 times 10 to the 6 meters, right? The distance from the center of the Earth to the surface, plus the distance from the surface of the Earth to the astronaut, which is 7,200,000 meters. So our radius, or our distance between, is going to be 1.357 times 10 to the 7 meters. This is an important step you'll have to remember. If you don't, and you just plug this number in, you're going to get a close answer, but you're going to get the wrong answer. It's one little step that you do at the beginning, but it makes a world of difference. So again, we are going to use our Newton's law of gravitation, which is Fg is equal to G m1 m2 divided by r squared. Our gravitational constant, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Mass 1, 68.5 kilograms. Mass 2, 5.97 times 10 to the 24 kilograms, divided by the distance between, 1.357 times 10 to the 7 meters squared. Again, this is a constant, this is the mass of the astronaut, this is the mass of the Earth on your formula sheet. And then this is the distance between that we found up here. When you plug that all into your calculator, you should get an answer of 148 newtons down. In our last example, we had 672 newtons when we were on the surface. Now when we're 7,200 kilometers away, we only have a force of 148 newtons. That tells us the farther we get away from a body of mass, the smaller or the weaker our force due to gravity is. The closer, you're going to have a bigger attraction. Farther, you're going to have a smaller attraction. So that's it for the topic. If you have any questions, let me know. If not, you're welcome to move on, and good luck.